Hello everyone, I am Mahesh DS working as Assistant Professor in Department of Electronics and Communication Engineering at STM Institute of Technology, Ujire. The topic what we are discussing is about introduction to LTE. So what is LTE and how it is brought into existence and what are the different parameters they have considered during the development of LTE. LTE is the next step in the evolution of mobile cellular system and was standardized as a part of the 3GPP release 8 specifications. Here, from the 3G technology to the 4G technology, when it was brought, so release 3GPP was shown with the specifications for LTE growth. LTE was primarily for high-speed data services, which is why LTE is a packet switch network from one end to the other end and has no support for the circuit switch services. Its sophisticated quality of service architecture allows the network to emulate a circuit switched connection on top of the packet switch connection. Or in other words, all the activities that are possible in the circuit switched connections are also possible in the packet switched connection. Or in other words, all the circuit switched operations are overlapped on the packet switch connection with the same quality of service. During the design, the few principles were to be followed, and for the first one is the network architecture, how the network should be and how it should support the service. LTE was designed to support packet switched traffic with support for various quality of service classes. So it should match with all the quality of services which are expected in the market. Previous generations of the network are also packet switched traffics, but this was achieved by subsequent add-ons to the initial versions of the standards. The example for this is by having the connectivity to the mobile phone, we added the services like GPRS and mobile data services by paying extra. And these services are packet switch services which are overlapped on or which are added onto the circuit switches connections like the voice calls. LT is different in the sense that it is a clean slate design. It's a new design, it's a unique design and supports packet switching for high data rate services from the start. All the activities happening in the LTE are in the packet switching network itself. LTE radio access network EUTRAN was designed to have the minimum number of interfaces while still being able to provide efficient packet switched transport for traffic such as conversation, streaming, real-time and non-real-time and also background classes. So here it is made to have the minimum number of interfaces. Most of the time it is end-to-end connectivity by tunneling through all the other network interfaces. Next one is the data rate and latency. What is expected? It is expected that the peak data rate for LTE is 100 Mbps and 50 Mbps respectively in the downlink and uplink when operating at a frequency of 20 megahertz with the frequency division duplexing channel size. So FDD is one mode of operation in LTE. Similarly, it has got a TDD mode also, time division duplexing mode also. The user plane latency is defined in terms of the time it takes to transmit a small IP packet from the UE to the edge node of the radio access network or vice versa, measured on the IP layer. Or it is the time taken by the small IP packet to reach from the user side to the first element in the network side or vice versa. So that is calculated to be the latency. The target for one-way latency is to be 5 milliseconds with unloaded network. The meaning of unloaded network is only one user entity is connected to the entire cell. If only one UE is present in the cell, then it is called as unloaded, and if that cell sends any information, sorry, that UE or cell sends any information in one direction, that is expected to be 5 milliseconds. That is the target in the design. The latency for other states are designed according during the state transitions, like the idle state and connect state, the latency varies. Then is the performance requirement. There are three different performance requirements that the LTE should match during the design so that it can be unique or it should be advanced. The first one is the spectrum efficiency, second one is the mobility and the coverage. Let us see one by one. Spectrum efficiency. The average downlink user rate and spectrum efficiency target is 3 or 4 times better than the previous version. That is baseline high speed downlink packet access, and the uplink, in the uplink path it is the spectrum efficiency to be increased by 2 or more. It is expected to be increased by 2 or more in the uplink path. So now the mobility. So what is mobility? It is the freedom for movement within the network. The mobility requirement for LTE is to be able to support handoff and mobility at a different terminal speeds. Whatever the speed at which the device is present, it should guarantee, the network should guarantee the services what it is being accessing. The minimum performance is expected to be with a lower speed of 0 to 15 km per hour, and with the small modifications or minor degradations in the performance quality, it can be accepted up to 20 km per hour, or in other words, again, the user can reach up to 20 km or speed movement with the smaller degradation or minor degradation in the performance quality. LTE is also expected to be able to sustain the connection of terminal speed. UE can reach up to 350 km per hour, but with a significant degradation in the system performance. This can be achieved when the device is in the idle state. Definitely, it is very difficult to achieve the expected target with the speed of 350 km per hour when it is in the connected state. And coverage, how long the signal can reach. For the cell coverage, the above performance targets should be met, and it can have the range of up to 5 kilometers. And for cell ranging up to 30 kilometers, a slight degradation in the user that we always experience when we are moving from the base station towards the other end where there is no base station, further base stations. At that point, we can experience a degradation in the performance, like voice drops, voice breaks, and discontinuous connectivity in the data, etc. Radio resource management. So how the radio resources are to be managed? The radio resource management requirement here in the design is to cover various aspects such as enhanced support for end-to-end quality of service. It has to be increased because 2G, 3G experienced huge drawback with respect to end-to-end connection, efficient support for transmission of higher layers, and support for the load sharing and balancing, and policy management and enforcement. All these are present in 3G, but it is expected to be enhanced here with the new technology. Next is the deployment scenario, how it is implemented, how it is brought into existence. There are two scenarios. One is a standalone deployment, other one is integrated with the existing technology. Standalone means when it is new to that particular area and it has got no internet working issues. That means there is no previous versions of any of the service providers in that particular area. Then it is called as standalone deployment. And integrated with existing UTRAN or GRAN deployment scenario, where the operator already has their previous versions of the network. Now it has to be matched with the previous versions so that it can cover the same geographical area. That is what we experience in the early introduction of LTE. We had LTE, that is 4G connection, 3G connection, as well as 2G connection in the same location from the same service provider. Now is the flexibility for spectrum and deployment. So how flexibility is? LTE was designed to be operable under a wide variety of spectrum scenarios, including the ability to coexist and share spectrum with the existing 3G technology. So when new technology is brought in, it should be backward compatible, so it can share now with the 3G technology as well. Services provided in the different geographical area often have different spectrums in terms of the carrier frequency and total available bandwidth. So this total spectrum now it is covering from 1.4 megahertz to 20 megahertz. Within 1.4 megahertz to 20 megahertz, LTE can get suitable to any of the frequency which is available in that particular geographical area. So it is called as scalable bandwidth. In order to accommodate flexible duplexing options, LTE was designed to operate in both FDD as well as TDD mode. So that is what I mentioned in the previous discussion. So we have both options for frequency division duplexing as well as time division duplexing, so that it can be made more flexible. Then is the interoperability with 3G and 2G networks. The calls made from 4G should go to 2G number and he should be able to call back. So that is interoperability 2G/3G we are discussing here. Multi-mode LTE terminals which support UTRAN or GRAN operation. should be able to support measurements of the handover from and to both 3GPP UTRAN or 3GPP GRAN systems. That is the previous versions of the network with acceptable terminal complexity and network performance. Definitely, when it is interoperable, there is a scenario where the calculation becomes complex, the terminal becomes complex, and the network becomes loaded and performance may degrade. But in the acceptable conditions, the multi-mode LTE terminal should be able to shift or switch for the UTRAN to measure its quality and support, and also make the handover from and to the 3GPP UTRAN as well as for the GRAN. So this is what we understood regarding LTE, the fundamentals and also the principles to be taken care during the design of LTE. Thank you.